Okay, so this will be our last section of geometry for us to finish up before spring break. So we'll finish up on this section however long it takes with all our interruptions. And then we will start reviewing what was considered the end of the year algebra stuff that you would have taken previous to coming into this class. And that'll be how we finish out the year. So we'll take notes on things, review things, practice them, and test on them. So if there's things that you heard last year but might have forgot, make sure you're asking lots of questions. Okay, we definitely won't spend as much time as we would if it was something brand new for you, because it shouldn't be brand new. This is something you would have passed last year. It just might be something that you forgot. So please make sure you're reaching out to me and we're getting the help that you need when we get into those algebra skills. Okay, so this is section 3.8, and you should have your vocab written on your own sheet of paper. So just make sure you label it as notes 3.8. This will be the very last section that I'll check when we do a notebook check. Okay, so analyzing polygons with coordinates. Okay, and then they just have this great picture. I guess, again, is what's in your book. Okay, so the very first thing that you were supposed to write was slope. It was a measure of steepness, and I asked you to draw the right triangle shown and label everything. Okay, so it was this drawing that was right here. That was the very first thing that you were supposed to write down. Okay, so it says the slope of a line or surface tells you how steeply it rises or falls in terms of a ratio. Okay, so that is a sentence that I want you to write where you have slope. Okay, so I'll pause for a minute and let you write that. Okay, we're going to add on to that definition in just a little bit, but for right now, you're just watching and listening. Okay, this ratio is found by using a right triangle. Recall that the sides of a right triangle that are adjacent to the right angle are called the legs. Okay, so these ones are called the legs. So the ones that are next to the right angle. Okay, and that's what adjacent means. And we actually learned about this in the last section, which ones are the legs and which one are the hypotenuse, okay? And then the remaining side of the hypotenuse is, or the remaining side is the hypotenuse of the triangle. And we always say it's the longest side, and it's the side that's opposite of the right angle, okay? So this is our hypotenuse. Okay, so again, we're gonna come back and add a formula next to this in just a minute, okay? And we'll do all the exercises at the very end. So we're gonna skip over this for right now. And that one, okay, and then our next definition was definition of a slope. So this is what I want you, not this whole thing right here, what I want you to add on to our definition of slope where we just drew our triangle. I want you to write this, and then this parentheses, and then write this as the ratio that they were talking about. Okay, so y2 minus y1 over x2 minus x1. Okay, so we, in that sentence, had ratio, you're writing the ratio formula next to it. So you don't have to write out this whole thing. Okay, and pause the video if you need to write this. Okay, so that was the definition of a slope. That was right by your drawing of the slope. So now we're down at the third line from your attachment that was on the calendar. Okay, not the example. We're going to where it said under the title, parallel and perpendicular lines, you were supposed to write the first 3 lines. Okay, so the first 3 lines that you were writing was this line, and this line. So if you need to pause the video to write that, you're writing that right now. Okay, so reading what we have here, it says recall from algebra, the slope-intercept form of a line is y equals mx plus b. Okay, so b represents something and m represents something when you're actually graphing things on a number line, okay, or on a coordinate graph. So it says where m represents the slope, so m is slope, and usually that's represented as rise over run, okay, and we'll come back to that in a minute when we work through those problems. And then b represents where it crosses the y-intercept. Okay, so they have some examples here, okay. So this is the part, if you were to graph it, that you would graph first. Okay, so they graphed where it crosses the y-axis at 2. So this is our y-axis. Okay, so at 2, they would put a dot there. So from there, what's in front of the x is the slope. Okay, so this is 1.5. So they didn't quite go up 2, but they went up a little bit more than 1. Okay, and then, so like example, if I were to say 3 over 2, if I were to write that, right here. Okay, if I was to write this as 3 over 2, that is equivalent to 1 and 1/2. Okay, so if we graph this part first, so where this is at, this is my rise, and this is my run. So this is my y direction, and run would be my x direction. And that's where we did our y minus y, x minus x, that slope formula that you wrote. Okay, so from where 2 is at, we would rise up 3. Okay, so here we are at 2, so we'd rise up 3, so 1, 2, 3. And then we would go over 2, so 1, 2. So if we were to extend this red line that they have right here, okay, that would cross through that. So if we were to extend this, okay, that would cross through that. But what they're trying for you to look at right now is the parallel and perpendicular. So if something is parallel, what you're looking at is the part where the M is at. Okay? So the part where the M is at either needs to be the same or what our definition says about perpendicular. So we're going to come back to this in just a minute. Okay? So these guys have the same slope. So we're coming to our parallel line theorem. In a coordinate plane, 2 non-vertical lines are parallel if and only if they have the same slope. Okay, so if we go back here and look at our drawing, both of these, which M is your slope, okay, we said this up here where M represents the slope, so whatever's in front of the X, as long as those two are the same, then we know that these two lines are parallel to each other, okay, which gave us this theorem. So if you did not get this theorem written down, which is the 1, 2, 3, fourth one down on your vocab, parallel line theorem, you need to pause this video and write that. Okay, so moving on to the next one now is perpendicular. So the slopes of perpendicular lines also have a special relationship to each other. The relationship is stated in the following theorem. Okay, so going on to the next page, if you need to pause this video to write perpendicular, do that. Okay, so perpendicular says in a coordinate plane, 2 non-vertical lines are perpendicular if and only if the product, and product means to multiply. Okay, so if you take the two slopes and multiply them, then it would equal a -1. Okay, so, and then they say any vertical and horizontal would be perpendicular to each other. Okay, so what we're looking at, and I'm just going to draw a rough sketch here for you. Okay, so if I had a line, okay, that was y equals, and say I had 1/3 x plus 5. And then if it was parallel, then I can have another one that would be y equals 1/3 x plus 10. Okay, so this would mean that these guys are parallel to each other. But if I needed something that was perpendicular, it would have to multiply times this to equal a -1. So if I had y equals a -3x plus 11, and I wanted to find out if this line and this line were perpendicular to each other, then I take the two slopes, okay? So I'd have 1/3 is one of my slopes. And product, again, remember they said to multiply? Okay, so if I multiply that times my other slope, which is a -3, they're saying if it equals a -1, then that means that they are perpendicular. Okay, well, we know that we can write all whole numbers over a 1. So if I said simplify this to know if it's equal to -1, okay, we can cross cancel, right? 3 can go into 3, which is 1. This is 1. These guys can cross cancel each other. So now I have a -1 over 1, which simplifies down to a -1. Okay, so checking to see if the lines are parallel to each other, you're just looking at what's in front of the x. Okay, so in front of the x, if they're exactly the same, then they're parallel. If the two are not the same, but they multiply to equal a -1, then they are said to be perpendicular. Okay, now if this was a +3, that would not work. Okay, because then I would cross cancel and I wouldn't have a -1 right here. This would be a +1. Well, a +1 divided by a +1 is not a -1. So one has to be a positive, the other one has to be a negative. Okay, all right. So another way that you will see it, and this is pretty much the same example, is they're saying that it needs to multiply to give you a -1, and they're reciprocals of each other. So it just basically, whatever equation you have, you're going to flip it. So if it was a fraction, you'd flip it and make it a whole number. If it's a whole number, you'd flip it and make it a fraction, okay? And then one of them is positive, one of these are negative. So even though those are variables, if I were to multiply to check that to see if it equals a -1, if I have A over B, and then I flip it, right? And then I just make sure one of them is a negative. So they put the negative on the B. Well, these B's would cross cancel, and these A's would cross cancel. But remember, in front of all of these variables is a 1. Okay, so it's just like what I wrote on the other page. These 1's are still here. Okay, these 1's are still here. So that's 1, and this one would cross cancel, and I would still have a -1 from this one over 1 from this one, which simplifies down to a -1. Okay, so perpendicular, you flip what the slope is, and then make sure one of them is positive, one of them is negative. Okay. All right, again, we'll come back to that. Okay, last formula. Okay, so you had your perpendicular line theorem that you wrote for the perpendicular one, and then midpoints. Okay, so pause this if you need to pause this to write this out. Okay, so the midpoint of a segment with the endpoints x1, y1, and x2, y2 has the following coordinates. Okay, so they want you to add the x's, so you would take the two x's, and sometimes you won't be adding. So if this is a -x, then you wouldn't be adding, you'd be subtracting. So the formula is just adding, okay? So x, whatever this x is, plus this x, and then you divide it by 2. That is the coordinate for the midpoint. That will be your x coordinate. Then you take the two y's, okay, and add them or subtract them, depending on if the y's had a negative number attached to it. And then that'll be your y coordinate. So when you graph it, now you have your x and your y to find the middle of the line. Okay, so pause that video if you need to write that. Okay, so now at this point, we're going to go back and we're going to look at the stuff that you have graphed on your graph paper. Okay, so I'm going back to problem number 1. Okay, so problem number 1, example number 1. You were told to find the slope of a segment with the endpoints at 2, 3, and 8, 6. Okay, so if you were to graph on your graph paper 2, 3, okay, so here's this point right here. There's your 2, 3, okay, and then 8, 6, so over 8, up 6, so that's this point right here. They're saying that if you make this into a right triangle, then you can count. So going left and right is your run. Okay, so they counted over 1, 2, 3, 4, 5, 6, so that's your run. Okay, then from there, now to get to the other dot, you went up 3. So 1, 2, 3. Okay, now you could also make your right triangle going this way. Okay, that also makes a right triangle. So going from this point to this point, if I'm starting to move, I would go up 1, 2, 3. So that's my rise. Okay, and now I'm going left or right, which I'm going right on this one. Okay, so I'd go over 1, 2, 3, 4, 5, 6 to get to my other coordinate. Okay, so it's north and south is your rise, and then east and west would be your run. Okay, so now the other thing that you would have on there, okay, so we're writing our rise and our run, is to use the formula that we had for slope. Okay, so the formula that we had for slope, it said that you had an x1 and a y1, okay, and then an x2 and a y2. Okay, so on your formula, it was y2 minus y1, right, because it's rise over run. And then whatever y you started with, you needed to start with the same one. So that would be x2 minus my x1. Okay, so you're going to put this on your graph because this would not be something that you already had on the book assignment. Okay, so if I take my second y is a 6, okay, I'm plugging it into the formula, and then subtract comes from the equation, not from a positive or negative, it's attached to a number. Okay, and then I would take my y1, so my y1 is 3. So now because I started with this 6, then below I have to start with the same x, okay, which is 8. Okay, so 8 minus is part of the equation, and now I take my first x. Well, my first x is a 2. Okay, so now we're going to simplify it. So again, this is my rise. My y's are my up and down, okay, my rise. and then these are my run. Okay, so we're going to check to see if we got the same thing as what we did when we graphed it. Okay, so 6 minus 3 gives me 3. 8 minus 2 gives me 6. Okay, so 6 is my run. That's what we got. Okay, 3 is my rise. Okay, that's what we got. Okay, now I want you to actually try this because it really doesn't matter if you start with your second y or your first y. It just matters to make sure that these match up. Okay, so you are going to add this again onto your drawing. We're going to show that it doesn't matter if you flip it. Because me, personally, I read left to right. So I would start with this one and then add the other one to it just because that's the way I read. Okay, so we're still starting with a y. So my y is 3. Okay, and I'm going to subtract my other y, which is 6. So now because I started with this y, this one up here, then that means I have to have that same x down below it. Okay, so that would be a 2 minus my other x, which is 8. Okay, so if I simplify this, 3 minus 6 gives me a negative 3. 2 minus 8 gives me a negative 6. And negative over a negative is the same as having a positive. So these two are exactly the same. So the catch is, it doesn't matter which y you start with, just make sure that the x below it is coming from the same parentheses. Okay, so that is our first example. Okay, so now we're going to go to our second example. Oops, too far. Okay, so example 2. So it says, find the slope of AB with the endpoints of 5, negative 3, and B being 2, 3. Okay, so you can do graph paper if you want to do graph paper and do rise over run. I think that'll take you a little bit longer, so we would use the formula on this one. Okay, so we're going to try it, and I want you to show me that the order does not matter. So if when you did these notes, you did it one way, I want you to show the other way as well, because I will check that when we do notes. Okay, so remember, when you're finding slope, it's y minus y, because it's rise over run. Go to graph things. Okay, so, and then x minus x. So we just make sure we start from the same parentheses. Okay, so I'm going to do what I did on the last one. I'm going to start with the first parentheses. Okay, so the y on that first parentheses is a negative 3. Then I'm subtracting what my other y is, which is a 3. Okay, now since I started with this y, then I need to start with this x. Okay, so then I would have 5 minus my other x, which is 2. So if you need to, if you're like, I don't remember which one's which, it's alphabetical. So xy, xy, this would be your first x and your first y, this would be your second x and your second y. Okay, just if you needed to do that, you don't have to. Okay, so we're going to simplify it. So a negative 3 and a negative 3 gives me a negative 6. 5 minus 2 gives me 3. So if you can simplify fractions, do it, because all of the answers, it's not that it's wrong, it's just that it'll be simplified when we read the answers. So if this can go in there evenly or be reduced, make sure you do so. So a negative 6 divided by 3 would give me a negative 2. Okay, so now we're going to show that the order did not matter. So I started with the first parentheses. Now I'm going to start with this parentheses. Okay, so now I'm going to go 3, because that's my y, minus my other y, which is a negative 3. Okay, so if I started with this y, then now I'm going to start with that x. So 2 minus 5. Okay, when we have double negatives, we change them to a positive. So 3 plus 3 would give me 6. And then 2 minus 5 gives me a negative 3. Okay, reducing this, 6 divided by a negative 3 gives me a negative 2. So if you do it right, these two should match up, and they did. Okay, so again, you don't have to do it both ways. I just want you to know that whatever way you choose, just make sure your x's match up below them, okay, to get the right answer. You can't just switch them. Okay, so our answer on that one is a negative 2. Okay, now we are going to our example 3. Okay, so you were supposed to draw this quadrilateral and label it QUAD and plot these points. Okay, so we had Q being at 1, 4. Okay, so you have this on your graph. Here's, they went over 1, up 4. There's your Q. Okay, and then graphing all these other ones. and they want you to say what type of quadrilateral it is. Okay, so besides on these just telling me what you think it is, you are going to have to tell me the slope, because this is actually how we prove it. Okay, so we're going to find the slopes of each of these sides. So if you have it graphed, you can do the rise over run. Okay, so I need to find the slope of this side, the slope of this side, the slope of this side, and the slope of this side. Okay, so if you did the rise over run, then you would count up. Okay, so this one I would count up. So here's 1, 2, 3, 4. Okay, so that's my rise. Remember, rise is on top. Over run. So now we're going over 1, 2, 3, 4, 5, 6. Okay, and then again, you could reduce that. So that would be the same as 2/3. Okay, so the slope for this line is 2/3. Okay, so then on this one, okay, I'm going to do this side, A side. Okay, so I'm going to start here and then go up to make my right triangle. So from here, I went up 1, 2, 3. So that's my rise. Okay, and then my run from that dot to that dot is going to be over 1, 2. So 3 over 2, which cannot be reduced. Okay, so 3 over 2. Okay, now I'm going to go to, oh, I made a mistake. So this one, we went in a negative direction, so that would be a negative because it goes up in a positive, but to the left, negative. Okay, so that should be a negative. So, okay, now I'm going to do this one here. Okay, so I'm going to start at this one and then go this way. So this is a positive direction. So I'm going over 1, 2, 3, 4, 5, 6. Okay, and that's my run though. So be careful of that because that's going left and right. So we're at positive 6. Okay, then from there I'm going to rise up. So that's going to be this number. Okay, and I'm going to go up 1, 2, 3, 4. Okay, so that's going to be a 4. And then again, reduce it if you can, which that one we can, which is 2/3. Okay, so now the only other one that we have is this side, what the slope of this one is. Okay, I'm going to start at this one here. Okay, and I'm going to go down. So that means my rise is a negative because I'm not going up, I'm going down. So that's negative direction. Okay, so there's 1, 2, 3. So I'm going down 3. But then from there, I'm going to the right 2, which makes it a positive. So over 1, 2. Okay, and then again, that can't be reduced because rise over run. Okay, so to prove that this is a rectangle, it looked like a rectangle, but it could have just been some type of parallelogram and not make 90 degrees here, because a rectangle has to have 90 degrees. This is where you check it. Okay, so on a rectangle, opposite sides would be parallel to each other. Okay, so they are. So opposite sides, so this side and this side would have to have the same slope, which they do. Okay, then this side and this side would have to have the same slope, and they do. So now to prove, that would just make it a parallelogram. Now to prove that it's actually a rectangle, then I would need to know that this side and this side make 90 degrees. And 90 degrees, another word for that would be perpendicular to each other. Okay, so the slope for this side was 2/3, and the slope for this side was a negative 3 over 2. So remember we said when we multiply them, they need to equal a negative 1. So if you don't cross cancel and simplify, if you want to just go straight across and reduce, you could do that. It's totally up to you. So 2 times negative 3 would give me a negative 6. 3 times 2 gives me a positive 6. So if you were to reduce that, it equals a negative 1. Okay? So that means, even though it doesn't look like it, because this looks more obtuse in this drawing, because those equal a negative 1, then we know that it is a rectangle. Okay? Opposite sides are parallel, and then the 2 adjacent sides make 90 degrees. Okay, so on that one, I'll be checking your slopes. Okay, and then you will tell me what the name of that shape is, which you would put rectangle. Okay, so another thing that you could have done, we won't go through and do that right now, but if you don't want to graph it, like this one was graphed for you, but say you have a problem and it has this, you don't have to take the time to graph it and then to find it. You can just do slope, okay? And you would just go in order. So I would do my y minus y, and then and because I started with 4, do my x minus x and get the slope for here. And then you would do it again now for these guys. Okay, so the y minus the y, and then the x minus the x, and then find the slope for these guys. So you'd have the slope for these guys, and then the slope for these guys, and then you would do this one now. Okay, so your y minus the y, and the x minus the x, and get the slope. And then the last one would be finding the slope of these guys. Okay, so the y minus the y, and then the x minus the x, and then get the slope for that one. And then you could start comparing. Do you have two pairs of parallel lines? Are the two that are next to each other, are they perpendicular? So I'll show you examples of that when we go to do the reteach so that you understand that you don't have to graph it every single time. Your choice. Okay, so moving on to example number 4 now. Okay, so on example number 4, it says you're going to sketch or draw triangle ABC with the vertices of 2, 6, 0, 0, and 4, 0, and use this triangle to test the triangle midsegment conjecture. Okay, so again, if you want to graph it, that is totally fine. Sometimes that helps you speed it up. Totally up to you. But what you're finding is they want us to find the midpoints. Okay, so we have a triangle, so I'm just going to rough sketch this. Okay, so we have a triangle that went over 2. Okay, so over 1, 2, and then up 6. So 1 and 2, 3, 4, 5, 6. Okay, so there is my A. Then the B was 0, 0. Okay, so that would be at the origin. And then C is over 4, 0. So over 1, 2, 3, 4, and then it doesn't go up on the Y. And that is my C. Okay, so what they're wanting us to find is to prove where the midsegment is at. So basically you're looking for the coordinates of where they would be at. Okay, so that we can find the midsegment. So remember, the midsegment is going to be where we can connect and make it parallel. Okay, so we want to find the middle of AB. Okay, so if I take these coordinates and you go to your midpoint formula, okay, your midpoint formula was to take the x's, so remember this is xy, xy, take the x's and add them. Okay, so if I added 2 and added 0, my other x, okay, and then we divide them by 2, because you're finding the middle of that line, not the distance of that line. Okay, so that's your x coordinate. And then now you do that same thing with the y. So the y, we would take 6 plus 0, and we would divide it by 2. So this would give me the coordinates of my midpoint. Okay, well 2 plus 0 is 2. And 2 divided by 2 would give me 1. Okay, so then doing that one, 6 plus 0 is going to give you 6. And 6 divided by 2 is going to give you 3. So the coordinate of the midpoint is 1, 3. Okay, so I would go over 1, and then up 1, 2, 3. And this would be the coordinates of my midpoint for AB. So now we need to do the same thing for AC. Okay, so looking at this one and this one. So we're going to do the exact same thing that we did to find this one. Okay, so I'm just going to erase this. Okay, so make sure you have this, like how you got these answers written on this example on your graph paper. Okay, so now we're finding AC. So A, I'm looking at my x and combining it with this x. So the A x is 2. I'm adding it to my C x, which is 4, and then divide it by 2. Okay. Then I do the same thing with my y. So I have 6 that I'm adding to my y on that one, which is 0, and then we divide by 2. Okay, so 2 plus 4 would give me 6. 6 divided by 2 is going to give me 3. 6 plus 0 gives me 6, divided by 2 gives me 3. So the coordinate is 3, 3. Okay, so I go over 1, 2, 3, and then up 1, 2, 3. Okay, so there's my other coordinate. So they're wanting us to prove, is this the midpoint of this one? And it would be, because these guys are parallel to each other. You have a flat line. Okay, 2 horizontal lines. Okay, so that's all you're looking for on that, is just what is the coordinates of those points. So next to this drawing, you need to write what that answer was, okay, which was 1, 3. And then next to this drawing right here, you're going to write the coordinates of that side, which was 3, 3. Okay, so you'll write those in those two spots where you have your graph. Okay, so this next one we're doing something similar, but you're going to try it on your own, and I'm going to stop the video. And this is the try this, okay? And this time, instead of it being a triangle, you're going to do a trapezoid, okay? So remember, trapezoids just are the same thing as a triangle, except this part will be cut off, okay? So you are going to graph, get there, hold on. You are going to graph this, okay? So you're going to graph these points, this one, this one, this one, okay? And then you are going to find the coordinates of the sides that you need to find. So remember, on a trapezoid, it has to be connecting the two non-parallel sides. So, and I'm only drawing this, this is not what yours will look like, but I'm only drawing this because you'll have this on some of the other worksheets, okay? So if you go to graph something and it looks like this, okay, to give you your trapezoid, they're not looking for you to find the midpoint of this side and this side. It's the two sides that are not parallel to each other. So you want to find the midpoint of this side and this side, okay? And you'll have a coordinate of x and y and x and y. Okay, so graph these, okay, and then know which two sides you're finding the midpoint of, and you're practicing the exact same thing that we did on the triangle. Okay, so you're adding the x's and dividing by 2, and then adding the y's and dividing by 2. And then that gives you your x and your y on one side, okay? So like if we were doing this one, we'd have the x and the y for this one. Okay, and then this other side, I would do it again. So I need to know the coordinate of this one to this one to do the adding of the x's and divide by 2 to get the other coordinate of this one. Okay, so you are trying this one on your own, and we will check that once everybody's done.